Students, in Laplace transformations we derived so many problems, solved so many problems. This session especially one special problem, Laplace of f of t is represented for integral 0 to infinity e power minus st f of t dt. This is the general rule. Earlier we studied this one. So, recap of this one, I am going to do two problems interestingly. Before that, we have to think about this result also. Laplace of t f of t is nothing but minus d by ds of Laplace of only this f of t. T for t, we have to introduce the derivative with minus symbol. Okay, let us start. For this problem, sin t, cos t, two terms, standard results. We know that Laplace of sin t is equal to 1 by s square plus 1, and Laplace of cos t is equal to s divided by s square plus 1. These two results are standard one, or otherwise Laplace of sin a t is equal to a divided by s square plus a square. Laplace of cos a t is equal to s divided by s square plus a square. These two are standard results. Here coefficient of t is 1, so I used instead of a 1. Yeah, then we can proceed. So, by applying this rule, this rule, first thing, Laplace of t sin t is equal to minus d by ds of Laplace of sin t. This is the rule. Is equal to minus d by ds of Laplace of sin t is 1 by s square plus 1, and again you know the derivative of u by v. Derivative of u by v is here v square, v into u dash minus u into v dash is the rule. Here u is 1, we can do, but even though I can use that quotient rule. U is 1, v is s square plus 1. So, here s square plus 1 whole square, and here s square plus 1. The derivative of 1 is 0 minus 1 dot. Derivative of this s square is 2s. Derivative of this plus 1 becomes 0. Then I can stop here. Yeah, minus of 0 minus 2s. So, minus 2s divided by s square plus 1 whole square. Yes, is equal to 2s divided by s square plus 1 whole square. Stop here. This is actually Laplace of t sin t. One small thing, by using here, come here, Laplace of f of t. Laplace of f of t is integral 0 to infinity e power minus st f of t dt. Then I apply this formula for this step, I will get integral 0 to infinity e power minus st of t sin t dt. Okay, applying for this Laplace of sin t dt is equal to Laplace of t sin t. Remember, this is Laplace of t sin t. But the question is integral 0 to infinity e power minus t. Here e power minus st. So, therefore, integral 0 to infinity e power minus t sin t dt is nothing but Laplace of t sin t, where s is, comparing these two, s is equal to 1, s equal to 1, not s tends to, s is equal to 1. So, Laplace of t sin t we derived 2s divided by s square plus 1 whole square, where s is equal to 1. So, 2 into 1 divided by 1 square plus 1 whole square. 1 square 1 plus 1 2, 2 square 4. So, 2 divided by 4 is nothing but 1 by 2. So I got that result. The first result is over. Then for second result, I can use the same space here. It's enough to do because the concept we studied here. Then I can go directly for the second result. Laplace of cos t is equal to s divided by s square plus 1. Laplace of t cos t equal to minus d by ds of s divided by s square plus 1 is equal to minus, again this quotient rule, v square is s square plus 1 whole square, v s square plus 1, differentiation of s is 1 minus s dot v dash is 2s for 1 0 equal to minus of 1 into s square 1 into 1 minus 2s square divided by s square plus 1 whole square is equal to minus of minus s square plus 2s square is s square minus into plus minus 1 on numerator, denominator s square plus 1 whole square. This is actually Laplace of t cos t. Okay. Now for this integral 0 to infinity e power minus t cos t dt is equal to Laplace of t cos t where s is equal to 1, as we studied in the previous one here, is equal to s square minus 1 divided by s square plus 1 whole square where s is equal to 1. By applying s as 1 here, definitely we will get 0 by 4. 0 by anything is 0. Okay, check, s is 1. 1 square 1 minus 1 0. So we got the result. Okay. So remember, the Laplace transformation is 0 to infinity e power minus st f of t dt is the key term, is an important title's meaning of title Laplace transformation. Integral 0 to infinity e power minus st f of t dt. So we applied this result and replacing s value here. Thank you.